Hi there, this is A-level physics, resistors in series and parallel. So the objectives are to learn or relearn from GCSE the circuit rules for series and parallel circuits, how to add resistors in series and in parallel, and then we're going to solve resistor problems for series and parallel circuits. So the rules for series circuits. So a series circuit is a circuit whereby the current that comes out of the battery or the cell can only flow in one direction. So this is a cell, the top bit, and that is the positive side, and this one is the negative side. So the long side's positive. Now current, or conventional current as it's known, flows from positive to negative, so in this direction. So in a series circuit, as the current flows around the circuit, the current at every point is the same. So that could be a first rule. So the current at all points, sorry, this isn't the neatest. Current at all points is identical. Okay. Now the voltage, so let's give this some random voltage. So say this cell has a voltage of 5 volts. Now the resistors that are in series, they would actually share the voltage. Whether they share it 2.5 volts each depends on the resistance. So maybe this one is 3 volts and this one would then be 2 volts. Or 2.5, 2.5, or 4.1. It depends on the resistance of the resistors. If they had equal resistance, then it would be 2.5 volts each. So the second rule, voltage is shared across components. And they must equal the supply voltage. So the 3 and the 2 in this example equals the 5 that's given. Hopefully that's okay. Let's move on to parallel circuits. This should be a recap of GCSE. So parallel circuits. So let's give this some random voltage. Let's say this is 5 volts again. So the current would come out of the positive side of the battery. When it gets to a junction, however, let's give it a random current. Let's say 2 amps. Maybe 1.5 amps goes this way. And maybe 0.5 amps goes this bottom way. So basically, when it gets to a junction, the current in a parallel circuit will split. It's pretty simple to identify a parallel circuit. The current has more than one path to take. Voltage, however, so on this top row, the voltage is 5 volts. On this row, the voltage would again be 5 volts. And on this bottom row, the voltage would be 5 volts. So in this instance, the voltage across this single resistor would be 5 volts, because that's the only thing on that row. The bottom one, let's say they're the same resistance, the total will be 5 volts. These may be 2.5 volts each, as these two bottom resistors are in series with each other. So the rules, the first one, we could say current splits and joins at junctions. If you sat there thinking, I know all this, then just fast forward to the questions, that's fine. And joins at junctions. And then secondly, the voltage, basically voltage is same on each row, is suffice. The supply voltage, same on each row. So on this one, there's 3 rows, the first one, second one, third one. They all have a voltage of 5. Right, let's move on then. But before we move on to the questions, let's look at, just remind the equations you should know. The ones that we're going to need for this PowerPoint are voltage is current times resistance, which is Ohm's law. Voltage is in volts. Current's measured in amps. Resistance is measured in ohms. Then we just need to know how to add resistors in series and in parallel. In series, we just add them together. And in parallel, we have to do 1 over the resistance. I'll show you on this next example. So example question, calculate the total resistance of a 4 and 6 ohm resistor connected in series. So in series, they would just be next to each other, like so. And resistors in series is really easy. So you've got the 4 and the 6, you just simply add them together. So the total resistance would be 10 ohms. In parallel, we have to add them as fractions. I'll show you how. So we've got the 4 and the 6 in parallel this time. So to do this, we do 1 over the total resistance, 1 over RT, is equal to, and then we add them as fractions. So 1 over 4 plus 1 over 6. If you put that in your calculator, that will give you 5 over 12. So 1 over RT is 5 over 12. So to get RT, we have to flip both sides. So RT would equal 12 over 5. And 12 over 5 is 2.4 ohms. Hopefully that makes sense. Let's move on. So if you want to have a go at these two, just pause the video and then I'll take you through the answers. So the first one, let's deal with the parallel combination first, the 2 and the 5. So 1 over the total resistance is equal to 1 over 2 plus 1 over 5. Put that in your calculator and then do the reciprocal. And the answer to the parallel section is 1.43 ohms. That should do. And then we simply just add the 4 ohms. So you could just leave the value in your calculator, add 4 as they're now in series, and we get 5.4 ohms. So the first section, or first one, is 5.4 ohms. So the next one, we've got the 5 and the 8 are in series, so we just need to add them together. So that would be 13 ohms. In parallel then with a 12 ohm resistor. And then we just need to do the 1 over RT, because they're now in parallel, is 1 over 13 plus 1 over 12. Add them together, then do the reciprocal. So the total resistance is 6.24 ohms for circuit 2. Hopefully you'll start to get the hang of these. These circuit problems, the more you do, the more proficient you'll become. So let's move on, let's do some more examples. So once I've got this one, just pause the video, then I'll show you how to complete it. Pretty straightforward. So the 2, 3 and 4 are in series, and the 5 and 6 are in series. So essentially that's a 9, you could swap that for a 9 ohm resistor. And at the bottom, 5 and 6, an 11 ohm resistor. They're in parallel, so just add them in parallel. So it's 1 over RT is equal to 1 over 9 plus 1 over 11. Put that in your calculator, then do the reciprocal. So that gives RT as 4.95 ohms. Let's move on to the next example. Nice and straightforward. If you want to have a go, just pause. So these three in parallel, so 1 over RT is equal to 1 over 2 plus 1 over 4 plus 1 over 6. Put them in your calculator, which is 11 over 12. Do the reciprocal, 12 over 11. So RT is 1.1 ohms. So this one's a bit trickier. So I want to find R1 and R2. So please pause the video, have a go, and then resume when you're ready. So we need R1 and R2. So the first thing, R3, we can just find the current going through. So if there's 2 amps in total and 0.5 amps goes through R2, that means that 1.5 amps goes through R3. So we need that. Then we essentially just need to know the voltage of R1 and R2 and R3. If we know the voltages, we've got the currents, we can find the resistances. So the only way to get the voltage is to know the voltage of the 2 ohm resistor. So to get the voltage of the 2 ohm resistor, we need to do current times resistance. And the current flowing through the 2 ohm resistor is 2 amps multiplied by the resistance of 2 ohms. So that gives us 4 volts across the 2 ohm resistor. The total, however, is 12 volts. So if 4 volts is used for the 2 ohm resistor, that means we've got 8 volts remaining. 12 minus 4 is 8. So across R2 and R3, we've got a total of 8 volts. And because R2 and R3 are in parallel, that means that the voltage across R2 and R3 is both 8 volts. So hopefully you figured that out. So the resistance 2 is equal to the voltage across 2 against the current, over the current. So the voltage is 8 and the current is 0.5. So the resistance R2 is 16 ohms. Then we can do the same for R3. So R3 is voltage divided by current. The voltage is 8 divided by the current, which is 1.5. 8 divided by 1.5 gives 5.3 ohms. 5.3 recurring. Hopefully that suffices. Let's have a look at the next one. So this question wants to find the voltage and current in the 4 ohm resistor. So if you want to have a go, just pause and then I'll take you through the answer when you're ready. So to get the voltage on the 4 ohm, the 3 ohm and the 2 ohm would be identical because they're in parallel with each other, and in parallel the voltage on each row is the same. So we need the total voltage. So to get the total voltage, however, we need the total current and the total resistance. So we need to add the resistances. So 1 over RT is equal to 1 over 4 plus 1 over 3 plus 1 over 2. And then do the reciprocal. And the reciprocal of that value is 0.92 ohms. So now we can get the total voltage. The total voltage, VT, is equal to the total current, which is 8, multiplied by the total resistance, which is 0.92. So that gives a total voltage of 7.38. If we end up with slightly different answers at the end, don't worry, it's probably a roundup error, because we're not being too disciplined with roundup errors at this moment in time, for this video anyway. So now that we've got the total voltage, the voltage across the 4 ohm resistor is 7.38 because they're all in parallel. So now we just need to get the current. So the current for the 4 ohm resistor is voltage divided by resistance. So the voltage is 7.38. You can use the full number in your calculator if you have it saved, divided by the resistance of 4 ohms. So that will give us a current of 1.85 amps. Sorry if that's a bit small. 1.85 amps. Hopefully that went okay. Let's have a look at the next one. So this time we need to calculate the current in the 8 ohm resistor. If you want to have a go, please pause. And then I'll take you through the solution. So we need the total current first of all. So total current is total voltage divided by total resistance. So to get total resistance, we need to sort out this resistor combination. We've got 2 sets of parallel resistors. So let's deal with the first one. So the first one, 1 over RT, is 1 over 4 plus 1 over 6, and then the reciprocal. So the reciprocal of that is 2.4 ohms. Then let's do the next combination, the 1 over 8 plus the 1 over 10. And then do the inverse. And that will give us 4.4 recurring ohms. So to get the total resistance, we just add those together. And we get, so the total resistance, RT, is 6.84 recurring, 6.84 recurring ohms. So the total current is the total voltage, which is 10, divided by the total resistance, the 6.84, the value you've just got. And that should give 1.46 104 amps. So we've now got the total, that's the total current that's flowing in. Well, it actually comes this way. Let me remove that this way. So what we need to figure out is how much of that voltage goes to the 8 ohm. If you're good at maths and can think like a proper mathematician, you could just do a ratio and figure it out. If not, then what we need to do is to calculate the voltage across this section, which is pretty straightforward because we've got the resistance of 4.4 recurring ohms. I'm just going to write this at the top. 4.4 recurring ohms. And we've got the total current. So we can get the voltage by just doing I times R. So the voltage of that section, that parallel section, is the current, the 1.46104, multiplied by the 4.4 recurring ohms, which is 6.49 volts. Now we've got the voltage and the resistance. We can get the current by just doing the voltage value of the 6.49 divided by the resistance, which is 8. And that will give us 0.81 amps. It's a bit busy, that question. It's quite a long-winded one, but hopefully that went okay and you managed to figure it out. Let's have a look at the next one. So a bit of a tricky one. This one wants you to calculate the effective resistance between X and Y in terms of R. So if you want to have a go at this one, I would advise definitely to redraw the circuit diagram and then attempt to do the calculation. So I will redraw it and then I'll probably run out of room, so I'll have to get rid of the drawing. So I advise that you write this drawing down regardless of whether you did it yourself or not, and then I can do the maths afterwards. Hopefully that's okay. So let's start from the beginning. So I'm going to put X at the top and Y at the bottom. So from X, we can go this way, go through a 4 ohm resistor, and then straight to Y. So on one side, apologies if this isn't the neatest, through the 4R, resistor, so 4R, straight to Y. Now the other side's going to be a lot busier, so let's go this way. So through a resistor R on its own, so resistor R on its own, to a junction, and at that junction we split in parallel and go through a 6 ohm and a 3 ohm together on opposite sides. So split parallel, we have a 3R and a 6R in parallel. They both join back together at this junction, so they join back together at this junction, go through R and then connect to Y. So go through R, then connect to Y. Hopefully that's okay. So if you want to get this, if you got the diagram wrong, that's the correct diagram. So if you want to try and complete the calculation now, please do. But I'm going to remove this now and then do the calculation. So the parallel section on the left-hand side, the 3R and 6R, they're in parallel. So let's do 1 over RT is equal to 1 over 3R plus the 1 over 6R. So the 1 over 3R would be 2 over 6R, if we give them the same denominator, plus 1 over 6R. So the total would be 3 over 6R, and then to get the total resistance we need to do the reciprocal, which is 6 over 3R. So 6 over 3R is 2R. And then above the parallel section, we've got a resistor named R, and below the parallel section, we had another resistor called R. Now that they're all in series, we can simply add them together. So we have R plus 2R plus R. So the total resistance on the left-hand side is 4R, 4 lots of R. Then on the right-hand side, we've got another 4R. So now, to get the total, we just need to do 1 over 4R plus 1 over 4R is equal to 1 over RT. I'll just write that there. So 1 lot of 4R plus 1 lot of 4R is 2 lots of 4R. And then we need to do the reciprocal value to get RT. So the reciprocal value is flipping this to give 4R over 2. And 4 divided by 2 is 2. So the total resistance in terms of R is 2R. Hopefully that went okay. If you want to redo this video, just rewind, do it again, practice the questions, and I'll see you soon.